Alright, so in this video we're going to look at the SI and base units that you are going to come across in the A-level course, specifically looking at most of the Year 12 ones. And this is going to be important later on when we look at using dimensional analysis as a way of solving problems that you don't know how to solve, essentially. Alright, so let's get a start. So the first thing we're going to look at is the fundamental or base unit. So every unit that exists in all of science or whatever you happen to use units can be expressed as a function of these 7 units. So it's important you know what they are, and we'll look at later on how we can essentially turn SI units into base units. Okay, so first of all, the base property, we've got mass. So hopefully you should be familiar with mass. So the base unit or the fundamental unit is the kilogram. Whatever they try and tell you in chemistry, it's not grams, it's kilograms. That's the base unit, and the symbol for that, as you should already know, is kg. The base unit of time is the second, and that's given the symbol S. Length, it's a meter, given the symbol M. Quantity, we measure in moles, so 1 mole is 6.02 times 10 to the 23 molecules or atoms, so that's how we measure the quantity of things. You'll use that more in chemistry than you will in physics, actually, but we'll get to that in the Year 13 course. And that's just given, it's not given a symbol, it's just called moles, or you might sometimes see it, I suppose, abbreviated to MOL. Temperature is measured in Kelvin, the Kelvin temperature scale, given the symbol K. You will probably quite often see it given in degrees Celsius as well, and you'll need to convert to Kelvin. You won't really come across Fahrenheit in the A-level course. You probably will if you go on to do like engineering or physics or something, because the Americans use it quite a lot. There's current, which you should be familiar with from GCSE. So amps, and it has the symbol. Oh, what's what the unit A? So that's what you'd write. And light intensity, which you, to be honest, won't really come across very much, is measured in candela, which is often abbreviated to a CD. So those are the fundamental units, and next we'll look at the different SI units, which is the units that you'll put into equations throughout the course when we come across them, and then the last part we'll look at how to go between two. So those are the 7. You need to know what those are and remember what their units are. Okay, so let's look at some of the SI units that will come across in the different topics. So let's have a look at what we'll come across in the mechanics course first of all. So we already had distance, or its vector equivalent displacement, and we know its SI unit is in meters. I won't write that all again. We know the SI unit of speed or velocity is meters per second because it's distance over time. You might see that written like this. That this form here is what you should get used to putting in. Most people write it like this. Acceleration is velocity divided by time, so it's meters per second squared, commonly written like this. Time is in seconds. Force, the SI unit is the Newton, which is given the symbol capital N. Mass, we already talked about, kilograms. Volume is measured in meters cubed. Again, our friends in chemistry will probably tell you it's in decimeters cubed or liters. They are wrong. Volume is measured in meters cubed, and that's what you'd put it into equations. Density is mass divided by volume, so it's going to be mass, so kilograms, divided by volume, so meters to the -3 there. Potential difference is measured in volts, named after Alessandro Volta, and is given the symbol V, surprisingly. Current we've already come across. We've got A, so we can see we're now into our electricity topic. Charge is measured in coulombs, named after a famous scientist who actually did stuff in all sorts of disciplines, given the symbol C. Resistance is in ohms, after the German physicist, which is given the symbol omega, as a capital omega. Angles you might find either in degrees, or as you get more advanced you'll be using radians much more, which is given the symbol you're familiar with, like this, or usually symbol radians to just rad. Energy is measured in joules, named after a famous thermodynamicist, given the symbol J. And power is watts, named after James Watt, who did a lot of work on the early engines, that kind of thing, and it's given the symbol W. So no real subtleties there. Lots of famous scientists that you will come across. Okay, so those are the SI units. There's probably one or two that you'll come across that I've left out here, but those are some of the most common ones you'll come across in like the mechanics, electricity, materials kind of things. You'll come across a few more, but we'll get to those during the course. So that's the simple bit. Let's look at converting between SI units and base units, which is a key skill that you're going to need to master. Okay, so there's a few key steps to turn an SI unit into a base unit. So the first thing you need to do is find an equation that expresses the SI unit you've got in terms of base units. And I'll show you what I mean by that. And then you might have to do that step again, so that equation might not have got it all into base units, so you might need to make another substitution. And just keep simplifying, so if there's things top and bottom, cancelling them out, those kind of things. So let's show you what I mean. Okay, so force, we know, is measured in newtons. So something we'll come across when we're studying mechanics is this equation, which you can dig out from your formula sheet. It's called Newton's second law, and it goes F equals ma, so the resultant force is equal to the mass times acceleration. So what that means in terms of units is that 1 Newton is a kilogram times by meters seconds to the minus 2, because it's mass times acceleration. And what we've got here is kilograms, base unit, meters, base unit, and seconds, base unit. So we've got that expressed in a base unit. And so that's what 1 Newton is in base units. Okay, so that's a very straightforward one. Okay, so potential difference we want to express in. So we know that one has the unit of volts, and a equation you'll come across later on is that 1 volt is 1 joule is per joule per coulomb, so it's energy divided by the charge. This equation will come across. So what does that mean? It means a volt is a joule coulomb to the minus 1. So we've got joules, which is not a base unit, and we've got coulombs, which is not a base unit, so we're not off to a good start. However, energy is a force times a distance, so that means a joule is, we've got it up here, so let's go straight in, kilogram meters minus 2 times by meters, so it's kilograms meters squared s to the minus 2. That's a joule. And charge Q is equal to current times time, which means a coulomb is an amp second. So all of that means we can express potential difference as, here we go, kilograms meters squared s to the minus 2, amps to the minus 1, s to the minus 1. So what? Let's just change that to a minus 3 and then get rid of that one. And we've got here a volt as a function of base units. So that one was quite a complicated one. You just needed to use several different equations that you have available to you. That's pretty much as complicated as it gets, but hey ho, that was fun. Okay, so power we know has is in watts, and power is the energy per second. So energy divided by time. What does it mean? That means a watt is energy. So what did we have? Energy it was kilogram meter squared s to the minus 2 divided by time. So s to the minus 1. So a watt is kilogram meters squared s to the minus 3. So you can see here that when we have like several questions together on this, you can use parts from your previous answers. So like here, I use this working out I done earlier in the later part. So do keep an eye out for work you've done earlier, which you can substitute in later. And that is how we turn SI units into base units. And this is something you'll be using when you learn about dimensional analysis.